So for the activity that you guys are going to do, you guys are going to have a lake of goldfish in the middle of the classroom. That's going to contain half of orange goldfish and half of pretzel goldfish. What you do is you take your plates that you guys have and you go and randomly select 10 goldfish from the lake. Make sure that it's completely random. You guys aren't allowed to look at the goldfish that you guys are choosing. Now that you guys have the 10 goldfish, you guys are going to separate them between the pretzels and the orange. And then you write down the number of orange and pretzel goldfish on your data sheet. So right here, you have 4 orange goldfish and 6 pretzel goldfish. Now with those numbers, you're going to have your p-value is the number of the dominant allele, which is the orange out of the whole entire population. So it's going to be 4 out of 10. So your p-value is going to be 0.4. Your Q is going to be the proportion of the pretzel out of the 10. So then it's going to be 0.6. Your P squared is just going to be your p-value squared. So it's going to be 0.16. Your 2PQ is going to be your p-value times your q-value times 2, which is going to be 0.4 times 0.6 is 0.24 times 2 is 0.48. Your q squared is your q-value squared, which is 0.6 times 0.6, which is 0.36. Now, that's going to be your first data, the data for your first generation. Now what you do next is you're going to randomly eat 3 of your goldfish. Mr. Ramirez is going to eat 3 of the goldfish of the population of 10. And make sure that it's completely random. Now that you've eaten those, you're going to go back to your lake of goldfish and randomly choose 3 more goldfish. Again, make sure that it's completely random. Now you have another population of 10, and you're going to do the same numbers again. But now you have 5 goldfish or orange goldfish and 5 pretzel goldfish. So that's going to be your numbers here. And then you're going to do the same things over here. You're going to keep doing the same ones. Now for the second table with natural selection, when you do that, you're going to eat the goldfish that are the pretzel goldfish. So now Ms. Ramirez is going to eat 3 pretzel goldfish. And then once you do that, then you're going to go back to the lake and you're going to randomly select 3 goldfish again. And now you're going to do the numbers for that one. So in this case, you have 7 orange goldfish and 3 pretzel goldfish, and then you're going to fill out the same things for P, Q, P squared, 2PQ, and Q squared. So the only time that you're choosing the goldfish that you eat is in natural selection. All the rest of the times you have to make sure that it's completely random.
So at the beginning of class, we had passed out these student data sheets. I'm going to need you to go ahead and bring these out now. We're going to do a little activity, but before we do that, we're going to further explain the formula once again. So P squared plus 2PQ plus Q squared is equal to 1, where P is equal to the frequency of dominant alleles. These are going to be the orange goldfish. Q is equal to the frequency of recessive alleles. These are going to be your pretzels. P squared is equal to the frequency of individuals that are homozygous dominant. 2PQ is equal to the frequency of individuals who are heterozygous. And Q squared is equal to the frequency of individuals who are homozygous recessive.
So here we did a sample thing with the populations with we did 5 generations, and we filled in the table when it's the table 1 with no natural selection. So that means everything's completely random. You're not choosing which ones you're eating. You're gonna randomly eat 3 of them and then randomly select 3 from the pool. And so when you do that, you're gonna get the 5 generations. and the numbers that you're gonna get are supposed to be relatively constant throughout the 5 generations. So it's gonna be 4, 6, 5, 5, 4, 6, 5, 5, 6, 4. That's what the numbers that we got for number of orange goldfish, number of pretzel goldfish. So let's say, for example, if you have a population of 1,000 with your 2 PQ values, it would be approximately 48% of the 1,000 would be heterozygous, and then down 5 generations later, you're gonna get the same number. 48% of the 1,000 would be heterozygous. Here, 36% would be the homozygous recessive for the pretzel color, and then 5 generations later would be 16% of the 1,000 would be the same thing, the pretzel color, because they're homozygous recessive. So it's kind of different, but it stays relatively similar. 3, 2, 1.
So now we're going to look at table number 2, and table number 2 is with natural selection. With natural selection, we are selecting against the pretzel goldfish, which are going to be your recessive genes, and we're going to favor your orange goldfish, which are going to be your dominant genes. So after 5 generations, these are the numbers that we accumulated. So if you've noticed, going from generation 1 to generation 5, the numbers steadily begin to increase for your dominant genes, which are going to be your orange goldfish. And as for your pretzels, they slowly begin to decrease. These are going to be your recessive genes again. So we look at our heterozygotes over here, we also notice that steadily they begin to decrease because we are going to be selecting for your dominant genes, which are your orange goldfish. That's it. Stop it. So now that we've done a simulated exercise and you got to see what the values look like for table 1 and table 2, now it's your turn to perform the goldfish activity. You should get numbers that are relatively similar to what we've gotten in table 1 and table 2. Have fun and enjoy eating the goldfish at the end of it.